Welcome everyone to Quantitative Reasoning. In this first chapter, we're going to talk about a concept known as unit analysis, which can also be known as dimensional analysis. And I'm sure you have some concept of this, but we're going to look at it in a more formal way in this lesson. We're going to look at some basic concepts in this section, and then in the next section, we're going to apply the basic concepts to more complicated questions and applications. So we're going to start off by looking at the definitions that we need to know. So the unit of a quantity describes what the quantity measures or counts. So, for example, if I answered a question and just left it as 5, we wouldn't know what that means. Is it 5 feet? Is it 5 quarts? Is it 5 cups? So the unit describes what it is that number represents. So it's very important that you label your answer with those quantities or those units. So now we're going to go through our first example, and we're going to look for the keywords that helps us understand what we need to do. It says, you are buying 30 acres of farmland at $12,000 per acre. What is the total cost? So the first thing when you solve any problem, you want to make sure you understand what the question is asking. And typically when you're looking at a math application, it gives you a whole bunch of information, and then the last question is usually the direct question that they're asking you, find this or calculate this. So in this case, we need to find the total cost. Now, intuitively, we would probably know that we would take 30 acres times 12,000 to find the total cost of the farmland. However, let's look at this in detail so that we can apply this when the questions get a little bit harder. One thing that we want to notice is because it's asking us for the total cost, we know that our final answer should be dollars. That's the units that we want to make sure that we end up with. Now, some keywords that I see in the question, the word of and the word per. In mathematics, the word of means to multiply. And per means to divide. So, what we're going to do now to solve the problem is we're going to use fractions. We always start with what we know, and we know that we have 30 acres of farmland. So I'm going to write my fraction of 30 acres. Make sure you put your units in there. And I'm going to put it over 1 so that our fractions line up. You don't have to do that, but that's my preference. Now, we have that there's $12,000 per acre. So I'm going to put here $12,000. Per means to divide, and the fraction bar is another way to divide as well, if you didn't already know that. Fraction bar represents division. So we have $12,000 per, so we divide 1 acre. Now, because of the way that I set this up, when we multiply fractions, we can divide out anything that is the same on the top and the bottom. So I have acres here, and I have acres here, so I can cross those off. So when I multiply across the top, the acres are gone. So I take 30 times 12,000. That's going to give me 360,000. And then across the bottom, I have 1 times 1. I'm not including the acre because I crossed that off. So I have 1 times 1. And then when I take 360,000 divided by 1, it's just 360,000. And notice that we wanted to make sure that we had dollars in our final answer, and we do. So we can write it with the dollar symbol, or we can actually write it like this. It doesn't matter. We can write it out in words. Some important things that you need to know when you are problem solving with Unix. The first thing is that you cannot add or subtract numbers with different Unix, but you can combine different Unix through multiplication, division, and raising powers. So just like if you think back to your algebra class from way back when, if I gave you the example of adding, let's say 3x plus 5y. You cannot combine these together because they're two separate things. They're x's and y's, so you can't combine them. But if we had, for example, 3x plus 5x, because these represent the same thing, I can add them together and say that I have 8x. So the same thing goes with Unix. If I said I had 3 feet and I wanted to add that to, say, 7 meters, you cannot combine these together because they are separate Unix, just like you can't combine the x and the y together when you add. You need to change meters to feet or feet to meters. They need to be the same in order to add them. Okay, another important thing that you need to know, we're looking at this one right here. When you complete your calculations, you need to make sure that your answer has the Unix that you expect. And this is what I had mentioned before. If it doesn't, then you've done something wrong and you need to go back and check your answers. So if I'm doing a bunch of calculations and I'm supposed to have feet at the end, the question is asking me to find how many feet. And I work everything out and I end up getting meters squared or something different. Then I know I did something wrong, so I can go back and check my work. And you can follow through and track your Unix, and that will help you find your mistake. Some keywords that will help you when you're reading these questions. We already talked about this one. The word per means division. So here's an example. If I saw a unit labeled miles and then divided by hours, that is the same thing as saying miles per hour. Per means divide. If I see an of or a hyphen, then that means multiplication. So, for example, if I had kilowatts times hours, that would be kilowatt hours. And if we wrote it with a hyphen, it would look like this. If you see something that says it's a square, then that means you're raising it to the power of 2. So if I see a unit feet and then I multiply it by feet again, that's the same as feet squared. And you can read that as square feet or feet squared. And the same thing goes for cubed. When you cube something, that means you're raising it to the third power. So if you see feet times feet times feet, that would be feet cubed. And you can also read it as cubic feet. All right, so now we're going to get into specifics about conversion factors. A conversion factor is when you have some kind of equality that relates one unit to another unit, but they're equal. So, for example, a conversion factor might be 12 inches is equal to 1 foot, or 3 feet is equal to 1 yard. These are conversion factors because they're an equivalent statement. What's on this side is the same as what's on this side. Now, when we do our calculations, And we use these conversion factors to solve a problem. We're going to write them as fractions. So these conversion factors can be written, let's look at this one first. So I can write it as 12 inches over 1 foot, or I can write it as 1 foot on the top over 12 inches. And although they don't look the same on the top and the bottom, we know that they're the same. 12 inches is the same length as 1 foot. And when we have a fraction that has the same quantity on the top and on the bottom, we know that this is equal to 1. So if I multiply this fraction by anything, it's not going to change the value of it. It's just going to rearrange the way that it looks. Same thing for this one. When you have a conversion factor, you can write it with 3 feet on the top and 1 yard on the bottom, or you can write it with 1 yard on the top and 3 feet on the bottom. Because 3 feet is equal to 1 yard, this is equal to 1. Both of these are all equal to 1. So if I multiply it by something, it's not going to change the value, but only the way that it looks. So if you think back, if I take 5 times 1 or 7 times 1 or -5 times 1, when you multiply 1 by anything, it doesn't change the value of it. So the nice thing about this is I have 2 choices on what I can use to help me solve it. And I just need to pick the one that's going to work for what I'm trying to solve for. So let's look at this example here that says using Unix to find a pathway. So the question says, how many crates do you need to hold 2,000 apples if each crate holds 40 apples? So in this question, even though it doesn't explicitly say what the conversion factor is, when you read this, you see that there's an equivalence in here. It says each crate holds 40 apples. So I can say 1 crate is equal to 40 apples. There's our conversion factor. So when we look at what the question is asking us, it says, how many crates do you need to hold 2,000 apples? So our answer should be in crates. Okay, so we're going to start off with what we know. We know we have 2,000 apples, and we want to figure out how many crates that's going to be. So we're going to start with what we know, 2,000 apples. I'm going to put this over 1 because that's my preference. My fractions will line up that way. Now, I want to get rid of apples because I want my answer to be in crates. I don't want to be left with apples. So I want to get rid of apples and keep crates. Now, because I can put 1 crate on top and 40 apples on the bottom, or I could put 40 apples on the top and 1 crate on the bottom, I can write it either way. I can pick the way that works for this problem. I want to get rid of apples, and in order to get rid of apples and cross it off, I need to have apples on opposite sides of the fraction bar. So I'm going to put 40 apples in the denominator and 1 crate on top. Now, if I had done it the other way around, where I put 40 apples on top and 1 crate on the bottom, my apples wouldn't cancel and I wouldn't get the Unix that I need. So now you can see I have apples and apples that I can cross off. That's the same on the top and the bottom. And so now to answer this, I just need to take 2,000 over 1 and multiply it by 1 crate over 40. I'm not putting the apples in there because they got crossed off. If you're doing this by hand, then you would across the top take 2,000 times one crate would be 2,000 crates. And then on the bottom, I would do 1 times 40, which is 40. And when I divide 2,000 by 40 now, I would get 50 crates. Exactly what we needed in our answer. So we know that we probably did this right. If I came out with apples here, then I know I did something wrong. I'm not really going to answer the question because the question wanted grapes. Now let me show you how you can do this on our GeoGebra calculator. When you open up one of your XYZ assignments, before you click on the start button to enter into the area where you answer your questions, there'll be the instructions for the assignment, and then underneath there you'll see a calculator button. When you click on that, this calculator that you're seeing right now will open up. So this is what you can use on all your assignments. And there's lots of different things that you can do with this that's very helpful. For right now, I'm just going to show you how to handle fractions on here. And as we need other features, I'll show you how to do that. But there's different menus off here on the left. You'll see it says Table, Tools. When you're doing just regular calculator stuff, you want to make sure that it says you're on the Algebra option. Then when you click on Input up here at the top, your calculator palette will open up at the bottom. And you'll notice on the left, you'll see lots of different structures like raising something to a power and the square root and things like that. And then on to the right, you'll have just the regular calculator keypad. So the question that we just finished was the one about the apples and the crates, and we ended up coming down to having to take 2,000 over 1 times 1 over 40. So to do that, on here, you're going to click on the open parentheses, and then inside the parentheses, you're going to hit 2,000. And then because we talked about per means division, I'm going to do 2,000 over 1. Then what I want to do, if I want to add more to this calculation, at the very bottom, you'll see these left and right arrows. You want to make sure that when you put in your next fraction, you're outside the parentheses. So I'm going to arrow over to move my cursor outside the parentheses, and I'm going to hit multiplication. So I'm going to take 2,000 over 1 times, and then I'm going to do 1 over 40. And that gives me the answer of 50. So this button down here that looks like an arrow pointing to the left, it comes down and goes to the left. That's your enter button. The button above that is your backspace button if you need to delete something if you make a mistake. If you're doing calculations with fractions, you can actually tell GeoGebra to write your answer as a fraction, because by default, most calculators will give you the answer as a decimal. So let's say I want to take 50 and divide it by 120. Okay, it's going to give me this decimal value. And notice that 50 over 120 is not completely simplified. When I hit the enter button, which is that line and then the arrow coming down right at the bottom right corner, I'm going to hit enter. And what will happen is you'll see a little purple box come up with a fraction symbol. So it will take that decimal value and put it back in fraction form. Now, whenever you put it in fraction form, using that purple button, GeoGebra will always put it in the most simplified form. So I'm going to hit the button, and it will give it to me as 5/12. So 50 over 20 is equivalent to 5/12 when it's reduced. So those are some things that you need to know. And then also, if you are not using your graph, I suggest that you take this bar right here and just pull it over if you're doing calculations and you need more room to see what's going on. Sometimes when it's all squished in there, it's hard to see what's going on. So you can move that bar and make it bigger so that you have more space to see your calculations. Okay, let's do one more simple example where we only need one conversion factor. And then we're going to move on to an example in which we need multiple conversion factors. So in this example, it says convert feet into inches. So I know my answer needs to be in inches. And I know that there's a direct relationship between feet and inches. I know what that is. It's 12 inches is equal to 1 foot. This is my conversion factor. It's an equivalence between two different quantities or two units. Now I know I could use either 12 inches over 1 foot, or I could flip it upside down and use 1 foot is equivalent to 12 inches. We just want to make sure that we pick the correct one that gives us what we want when we're solving the problem. So since we're starting with 9 feet and we want to convert it to inches, I'm going to put 9 feet over 1. And it's really important, it seems like a silly thing, but it's really important that you put feet in here so that you keep track of where you're supposed to be putting what, if it's in the denominator or if it's in the numerator. If you forget that feet there, it's going to make it hard to tell, and then you might end up using the wrong conversion factor. We want to get rid of feet and we want to be left with inches. Inches should be in our answer. Because I want to cancel that feet on the top in the numerator, I want to make sure that I have feet in the denominator, so I have it on opposite sides of the fraction line and I can cancel it out or divide it out. So I'm going to put 1 foot is equal to 12 inches. Now by doing that, I have feet here that I can cross off, feet here that I can cross off, and so what I'm left with is 9 times 12 inches. I crossed off the feet on the top and the bottom, so I don't have the feet there anymore. And that's all over 1. So when I put that in on the calculator and I do 9 times 12 divided by 1, I'll get 108 inches. Okay, let's look at this example here. That's a little bit more tricky only because we have to use multiple conversion factors, because most people don't know the direct relationship between days and seconds. It's just not commonly known. So we're going to need multiple conversion factors here. We want to change days into seconds. We want to know the number of seconds, so seconds should be in our answer when we start with 94 days. So I'm starting with 94 over 1, and this is days. Now, I don't know directly how to go from days to seconds, but I do know that there are 24 hours in a day. So that's one conversion factor. 24 hours is equal to 1 day. Now we just have to figure out which one of those values is going to go on the top or the bottom. We don't want days in our answers, so I'm going to put 1 day on the bottom, and I'm going to put 24 hours on the top. So now I got rid of days. So if I were to multiply this out right now, my answer would be in hours because that's the only unit I have left. But we don't want hours, we want seconds. So we're going to put in another conversion factor. I know that in 1 hour, that's 60 minutes. I want to get rid of hours. I don't want hours in my answer. So I'm going to put 1 hour on the bottom and 60 minutes on the top. And that will allow me to cross off the hours. We only have one more left to go. I do know the relationship between minutes and seconds. I want to get rid of the minutes so that I'm left with seconds, because that is what the question is asking us to find. So I want to make sure that's in my answer. I know that 1 minute contains 60 seconds. So now I can cross off the minutes, and I'm left with all of these calculations. I've got rid of my days, my hours, and my minutes. And so what I have to do now is go right across the top, 94 times 24 times 60 times 60, and then in the bottom I have 1 times 1 times 1. And this is what I'm left with. It's with seconds because that's what's left for the units. Now when I multiply that all together, I'm going to get 8,121,600 seconds. So you want to think of this when you're doing a chain of conversions. You want to think of it like a puzzle. You want to rearrange your conversion factors in a way that everything that you don't want cancels and what you do want doesn't cancel. So now in this example here, it says example carpeting a room. You want to carpet a room that measures 12 feet by 12 feet. So they took 12 feet times 15 feet. And that gave them an area of 180, and this is feet squared. When you multiply something twice together, you're going to get the squared, right? 3 times 3 is 3 squared. You can do that with units as well. Okay, so this is the area of where we want to put carpet down. It says the carpet is usually sold by the square yard. How many square yards of carpet do we need? So we know what the area is for the carpet in terms of feet squared, but the question tells us that we need to figure it out in terms of square yard instead, because that's how the store sells it. So we're going to start with what we know. We have 180 feet squared over 1. Now, I'm going to rewrite this. Feet squared, remember, I'm going to rewrite this now so you can see. This is feet times feet. Now, there's a reason I'm writing it out like that, and you'll see why in a minute. Let's see. We need to determine the number of square yards. I know that there's a direct relationship between feet and yards. There's 3 feet and 1 yard. So what I'm going to do is I want to cancel out the feet. So I'm going to put feet in the denominator. So I have 3 feet is equal to 1 yard. But when I cancel this foot out here with this foot here, notice I'm still left with 1 foot on the top. And we don't want feet in our answer, we want yards squared. So to handle this, what I'm going to do is I'm going to multiply again by 1 yard over 3 feet. That way I can cancel off the feet here with this last feet here on the top. And now I'm left with yards times yards on the top, which is yards squared. So once we get rid of the 2 feet in the top and the 2 feet in the bottom, what we're left with is 180 times 1 yard times 1 yard times, and then in the bottom we have 1 times 3, which gives me 180 yards squared, because it's yards times yards, over 9. And now when we divide that, we're going to get 20 yards squared. Notice in this question here, it's talking about cubic yards, so we know we're talking about volume. And this example is talking about filling a planter. So how many cubic yards of soil are needed to fill a planter that is 20 feet long by 3 feet wide by 4 feet tall? So to find the volume in feet, if we think about this planter, so it's saying it's 20 feet by 3 feet and then 4 feet tall. That's a big planter. So to find the volume of that, I'm going to take length times width times height, which would give me 20 feet times 3 feet times 4 feet. When I multiply that all together, I am going to get 240 feet cubed. So the volume in terms of feet cubed is 240 feet cubed. Now we got to change that to cubic yards. In this case, because we have feet cubed, that's 3 of them. So I'm going to write it out as feet times feet times feet. So I have 240 over 1, and this is feet times feet times feet. Now I know the relationship between feet and yards, but because this is cubed, I'm going to have to do it 3 times. So I have 3 feet is equal to 1 yard. That's going to cancel out this foot with this foot. I still need to do it 2 more times. So I have 1 yard is equal to 3 feet. So this is going to cancel out with this now. 1 more time. I have 1 yard divided by 3 feet. So that's going to give me now no more feet. And I'm left with yards times yards times yards, which is cubic yards. So across the top, I have 240 yards cubed. Across the bottom, I have 1 times 3 times 3 times 3. And 3 times 3 times 3 is 27. And I don't need to put the feet in there because we canceled out the feet. So my last job is to take 240 and divide it by 27, and that's going to be approximately 8.9 yards cubed. So one last conversion that we're going to talk about is currency conversion, and that's pretty common in everyday life, especially when you're traveling. So we have this table here. Keep in mind that these values change day to day. So what we're using right here may be a little bit old. It should be close, but if you look online, it may be a little bit different. So let's use this right here as an example of how to read this chart. We're going to use the European euro compared to dollars. So when we look at the dollars per foreign, what that's telling us is this is $1.32 per means division per euro. So every euro is equivalent to $1.32. When you look at this column, that means foreign per dollar. So the amount of the foreign money per dollar. So that's going to be 0.7576 euros per 1 US dollar. So in this next example, it's going to get a little bit more tricky because we have 2 units to convert at the same time. When we read this, it says a gas station in Canada sells gasoline for $1.34 Canadian dollars. That's what the CAD stands for. What is the price in dollars per gallon? We're going to use the currency exchange rates on the previous slide. So we have Canadian dollars, 134, and that is per liter, so that's 1 liter down here. We need to change Canadian dollars into US dollars, and we need to change liters into gallons. So this is what we eventually want to get, dollars per gallon. If you look at the chart on the previous page, we have that 1.005 US dollars is equivalent to 1 Canadian dollar. And I'm putting the Canadian dollar in the denominator so I can cross it off. So now I'm left with US dollars in the top, which is what we want. Looking at this, we want dollars per gallon, so that means we want dollars on the top and gallons on the bottom in our final answer. We've got the dollars in the top, now we gotta do gallons. If you look up on your conversion chart that I gave you in your reference sheet, you'll see that 1 gallon is 3.785 liters. So since I want the liters to cancel, and liters is in the denominator over here at the beginning of our chain, I am going to put liters on the top of the fraction. So I'm going to put 3.785 liters. and that gives me 1 gallon. Now, because liters here is in the bottom and liters here is in the top, they're on the opposite sides of the fraction bar, so I can get rid of them. And now what's left, the only units that are left is dollars per gallon. Dollars on the top, gallons in the bottom, which is exactly what we wanted. So now we just have to work out that chain of calculations. I got rid of the Canadian dollars, so I'm left with 1.34 times, I have 1.005, and I'm going to leave the units there as dollars because we didn't get rid of that. And then times 3.785. We got rid of the liters, so I'm not going to add that in. Then on the bottom, I have 1. I crossed off the liters, so I don't need that. Times 1, crossed off the Canadian dollar, so I don't need that. And times 1, and then gallon. We still have that down there. When I multiply all of that out, I'm going to get that it's approximately $5.10 per gallon.